Hello everybody, this is a quick example of how to use Excel to calculate standard deviation. I'm going to show you a couple ways to do this. The first is what I would refer to as the easy way. It's just using your data analysis toolpak to use the descriptive statistics function to get the standard deviation. I'm also going to show you how to do it by hand using this formula. You could do this actually by hand in pencil and paper with a calculator if you chose to. I like to use Excel because it just quickens the process of getting some of these figures. Remember, the formula for standard deviation is S equals the square root of sum of x minus x bar squared over n minus 1. And what that means is you take each data point, subtract it from the mean of that data, you square it, and then you divide by n minus 1. After you add those together, then you take the square root of that. And remember from the textbook and from our previous recording that what standard deviation tells you is how far on average each point is away from the mean. So it's a measure of the spread of the data. If you have data that's spread out quite a bit, what you have is a large standard deviation. If you have data that's bunched together more closely, then you have a lower standard deviation or a smaller standard deviation. So what I have here is an Excel spreadsheet that I put together that has a column for the raw data, which would be whatever our data was from our study, the mean, the data minus the mean, which is this portion under here, the data minus the mean squared, which is this whole piece, and then we're going to go down and calculate the sum of the data minus mean squared, the sum of the data minus mean squared divided by n minus 1, and then we're going to calculate the standard deviation from that. So here's an example of some data points. Maybe this was a test that somebody gave. Out of 100 points, these were the scores. So you've got a 40, an 85, 95, 70, 50, 30, 65, 90, 75, and a 65. So already we should be able to take a look at this and get an estimate for how spread out we think the data is, considering that we're going from 40 all the way up to a 95, which is quite a good spread in the data, or excuse me, here's even a 30, so a 30 up to a 95. We're going to have quite a bit of spread of the data. I'd expect the standard deviation to be fairly high. But we're going to have to calculate that out to figure out what the actual number is. So first of all, we'll do it the easy way using the data analysis toolpak. So I'm in the data tab here. I'm going to go to analysis and look for our tab on the descriptive statistics, which is right here. Click OK. Now it wants us to put the data range in. So here's our data range. These 10 items. We have summary statistics already listed. I didn't include a label in the first row, so we're going to leave that unchecked, and then we have the columns here. So rather than have a new worksheet, I'm going to have a data range, and I'm going to go ahead and pick that data range to be over here so it's kind of out of our way. Oops. And what I've done here, if you do this, is when I clicked on this, it automatically took me back up here. So now I've got to re-put in my data. So my data range is these items. The output range is what I was intending to do before. I'm going to put it over here and click OK. So you can see it's already can tell us what the mean is, the standard error, the median, the mode, standard deviation, which is what we're looking for, and then some other items that we'll be talking about. So let's go ahead and use Excel to do this by hand. The first thing we need to do is to find the mean here. So I'm going to do equals to say as if, go ahead and get a formula in there. Average, because that's what Excel calls it. Pick my data points. And 66.5, which we have right here. So I'm going to go ahead and put 66.5 in for my mean. Copy and paste those numbers down here, so we'll have the whole list of them. Now what we have is the raw data, so we have each data point, and we have the mean x bar here. Now we're going to calculate each data point minus the mean. So equals this item minus this item. And of course the item here is negative because our mean was 66.5 and we were at 40 here, so we're 26.5 points under the mean. I'm going to go ahead and copy this. If I just do a copy and paste, then it's gone ahead And for each one of these, it's done the same thing. So we see that we have some that are positive and some that are negative. And keep in mind that that's the purpose of squaring this here. Because if we were just to add these all together right now, we'd have some of the positives and some of the negatives crossing each other out, and we don't want that to happen. That would give it the impression that all the data points were right at the mean, at 0 points away from the mean, when in fact, that's not the case, obviously. So we're going to square it, which is going to get rid of our negative numbers. So equals, I'll just take this item, use the asterisk for times, I'll just say times itself for square. Now it's positive. So copy that, paste it down here, and there are the data minus the mean squared. So data minus the mean squared. Now the summation means we have to add all those together. So here, I'm going to take it, I'm going to say sum. I'm going to pick my data points. So there's the sum of the data minus the mean squared. So this is this part right here. Now I'm going to take divided by n minus 1. So what is n? Well, n is the number of points we have. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10 points. So 10 minus 1 is 9. So I'm going to take this, which was the top, divided by 9. Now that gives us this whole portion under the radical. So to find the standard deviation, now I have to take the square root. And we'll find out later that this number right here is actually referred to as the variance, which is an important part of formulas for other statistical tests. But because we want to have units themselves and not units squared, like points squared, we're going to go ahead and square root this to get rid of our previously squared term. So equals square root is SQRT. I'm going to go ahead and pick my number. And 21.350, which we had here. So you can see you can use Excel to find out these pieces, and it does back up what we knew from here. We know that this is fairly spread out data, and we know that the mean and the standard deviation, even the range, will show these items that we got this spread out data. So we have a lot of spread around this particular mean. And you can see that if we had looked at 66.5 over here, we have quite a bit of numbers that go all the way from 30 to 95 around it, so a lot of variance. The nice thing about doing something in Excel is pretty easily you could change these items and change the numbers and see how that affects your overall data. So rather than just change it right here, I'm going to go ahead and copy some of our information here and paste it down here. And we'll also copy this one so we can compare it. So let's go ahead and change some of our information and see how that changes our numbers here. So instead of having large spread in our data, let's say that we had the test where everybody scored fairly close to each other. Let's do 85, 85, 90, 87, 84, 82, 83, 89, 90, and 87. So now we have much less spread around our mean. We're going to have to recalculate this, and the new mean is 86.2. So since this was just copied, we're going to have to change this, 86.2. Copy this, paste it down. So doing this, now we have new calculations. You can see that our data minus the mean is much smaller numbers all the way down. Now our standard deviation is 2.8596. So you can see that it's much lower than here at 21.3, but also we have less spread. So again, if we wanted to take a look at how we could use the data analysis toolpak for this, select descriptive statistics, scroll down, my new data input range is here, my output range, we'll put down below here, and there we are. So get the same information in the future. This using the data analysis tool pack is the easiest way to go, but it is good to try this a couple times just so you understand what it is that the formula is saying and how it shows the spread around the data. If you do have any questions about this, please feel free to let me know. We can go through other examples or we can just talk more about this particular video. Thank you very much.